got is 4 shear pins at the base of the column with a jig attached to the column and lassoed around the column with 160 tonne jacks on top that we are actually putting the load back down through the frame and into the column. This has proved pretty successful and it's working very well. Basically what we've got is a high grade bar that we've machined and we've cored holes into the column. These pins go into the column and then our stressing frames sit on there and all the loads transferred back down through the column. The pins look very difficult to get in, and which they are, and we need to have them very tight. But once we've jacked and all the loads come on, the concrete actually sort of does crush slightly, so the pins do pop out easily.
Everything is ready, it's all assembled.
We've got to go 14 millimetres, so the difference between the bearing as it is now and the new bearing is 4 millimetres, and we like to have 10 millimetre clearance. So Peter's got the control with the pump and we just measure as we go in incremental lifts.
At the moment I have 128 tonnes, or nearly 130 tonne, between the 4 jacks just to bed everything in. There are 5-degree swivels on the top of the jacks just under the steel plates. That gives them a chance to adjust themselves, and now that I've done that and pushed it, I'll push the retract button and let the weight off it, and you'll see the hoses jump, and now the weight is gone and everything's in a relaxed state again, ready for the big push.
This is the last grid line where we have the building above, and the loads were a lot higher. So what we've had to do is introduce an extra set of jacks. So we're effectively able to lift 600 tonne here. The 2 supplementary jacks on the side can do an additional 150 tonne. This grid line had more load imposed on it, and the bearings actually oozed a lot more than the other columns throughout the structure. With the load, the rotation is a lot more, so we've actually introduced some chain and some twitches to stop any rotation of the actual strut.
On the previous column we had 4 jacks with a capability of 64 tonne per 1,000 psi. We now have 6 jacks with a capability of 84 tonne per 1,000 psi. Everything is all set to go. All the jacks are in place. Everything's all tight. We give it an initial push, take it up to a couple of 100 tonnes to settle everything in, then let it go again, and then go around and check everything.
We're just checking to see if there's any micro cracking, just from where the shear pins are and where the actual load transfer is into the column. So sometimes we exhibit little cracks, but this one's performing pretty well. There's no cracking at all. We're jacking it up incrementally, and we're about 10 mil clear of the bearing. Then we insert the bearing and lower it down and remove the jacking frames. What we're having to do here is just raise the roof a bit higher because we can't quite get the shim in. So Peter's just opening these valves to the jack here, because the 2 jacks on the outside are double acting rams. So we've got to open the flow back so it can pump back to the hydraulics back to the pump.
We're approaching 15 mil of lift.
On this particular grid line, because we were directly under the Sky Metro building, we're doing a monitoring of the columns. So we've got a surveyor upstairs with an RL, and he's constantly checking that level as we are lifting from below. And we're in radio communication, so we can indicate to him what we're experiencing down below and what they're visually experiencing up on the facade upstairs. And it's all behaving as planned, so it's worth doing the monitoring. So we're actually going to monitor every column along this grid line. Now what we've got to do is just lock off the jacks, just so that we can lower them down and take the shim out. So they're going to be supported on the two sides and the north one.
Coming down.
We've got the neighbour next door here on the other grid line. That's already been had its bearing replaced, and the one east hasn't. So we've got a bit of a tent sort of pole effect, where as you replace the bearings and they stay up at their new 39mm, they inherently stay up a bit higher than where they were. This sort of situation doesn't come around that often, so it is specialised, and what we've done is involve people with the experience in the hydraulics and heavy engineering. So that's how Peter Rafferty got involved, and I also got Wolfgang Schank to do some of the temporary works designs. The team here, Sire, Peter and Glenn, and basically they've worked all different hours of the day, 4 in the morning, 6 in the morning, 11 at night, depending on what sort of stages we were. So yeah, I think we've 24 hours around the clock we've replaced the bearing at the Aotea Civic car park upgrade.